Hello friends, so we will see today the remaining part of the amphetamines. Today our topic is how to synthesize these amphetamines and their impurity profiling. Different methods are used worldwide and there is no any particular method is involved for the synthesis of these amphetamines in the laboratory. In any particular method, the impurities produced are different. But when we will study in detail these methods, then some impurities are frequently occurring in that particular method. Okay, so in our syllabus there are three methods are given. The first one is Leuckart synthesis of amphetamines. Leuckart synthesis of amphetamines. This synthesis of amphetamine is suggested by the scientist Leuckart. And what are the impurities produced during this synthesis, during this production in the laboratory? That we have to see. Okay, so very simple reaction is there. So this is the BMK, that is benzyl methyl ketone. So this is a ketone moiety. This system is known as benzyl. This is methyl part or methyl group is there. This is benzyl group, and CO carbonyl group is there in between these two, alkyl and aryl group. So the name is benzyl BENZYL. It's not benzene. Benzyl methyl ketone, BMK. Okay, benzyl methyl ketone is there, and it reacts with what is this? Formamide, HCONS2. So the reaction between benzyl methyl ketone and formamide in presence of oxidizing agent hydrogen peroxide H2O2. Okay, so it will give this intermediate. This CHO moiety will oxidize into carboxylic moiety, carboxylic acid moiety, and then in methanolic HCl, this moiety will be converted to our target molecule, that is amphetamine. Okay, so the decarboxylation may takes place here, and here minus CO2 molecule may escape, may be knock out from this molecule, and this hydrogen goes to this nitrogen, and our target molecule amphetamine is produced. Okay, so this is a very simple reaction between two molecules, that is benzyl methyl ketone and formamide. The most important here from the analysis point of view, here we are not stressing our focus on the synthesis, but our most important part here is the impurity profiling. In any method, in any synthetic method or in any production, some particular impurities are produced, and that impurity produced in that particular reaction we have to analyze. We have to clarify that which type of impurity are producing in that particular reaction. This is the important case for the analytical point of view. Okay, so that's why impurity profiling means impurity means impurity. And what is profiling? Profiling means to collect a data of which type of impurities are present or producing in that particular chemical reaction. It is known as impurity profiling. In which class it is present, or what are the functional groups present, or what are the sources of these impurities present in that all synthetic method. Okay, so this is known as, in short, impurity profiling. So what are the impurity profiling in this Leuckart synthesis? Okay, so the first impurity is this one. So it is a pyrimidine moiety. This is a benzene ring, simple, and this is pyrimidine ring. So the two nitrogen atoms are present at 1,3 position to each other, and this is also aromatic, and one methyl group is present to the 4th position of this pyrimidine ring. So numbering is starting from this 1, 2, 3, 4. So it is 4-methyl 5-phenyl pyrimidine. This is the name of this molecule, and this impurity is produced in this Leuckart synthesis. Then this is PSCS2, that is benzyl pyrimidine. Another type of impurity is producing in this case, it is benzyl pyrimidine. The next one is, in this case it is N-formyl amphetamine. If it is NH2 here, if NH2 is there, we call it as amphetamine, simple amphetamine, but one hydrogen atom is replaced by the formyl group, so it is called N-formyl amphetamine. N-formyl amphetamine is the impurity. Okay, so these 3 to 4 main impurities are producing, or they are producing in the Leuckart synthesis of amphetamines. Okay, so this is the first synthesis. Now second one is a reductive amination. Reductive amination, so reductive amination means we are doing amination of that, but we are doing amination reaction on that carbonyl compound, and after that you have to do reduction. Okay, so benzyl methyl ketone is again taken and it is get reacted with ammonia. Okay, so ammonia reacts with ketone, any ketone, it gives imine. So CH double bond C and C double bond N, this is known as imine. This is C double bond N is called as imine, or it is also called as chip base, is formed by the reaction between BMK and ammonia. So this imine is then reduced by using hydrogen gas at high temperature and high pressure. It gives our target molecule, that is amphetamine. Okay, and again the synthesis is different than the Leuckart synthesis. The title is reductive amination of benzyl methyl ketone. This is BMK, benzyl methyl ketone. Okay, and as the procedure is different, as the method is different, so the impurities produced are also different here. So in this case, this impurity is this type of impurity is produced in this reductive amination. Then N-acetyl, the acetyl group is present on this nitrogen of amphetamine. So N-acetyl amphetamine is produced as impurity in this case. Okay, then okay, so these are the two most important impurities formed in the reductive amination reaction. Then the third one is a nitrostyrene synthesis, the nitrostyrene synthesis of amphetamine. This is the third reaction used worldwide for the synthesis of amphetamines, but this third method is not widely used because the first two methods are very easy and they are giving best results. Okay, so the nitrostyrene synthesis, the starting compound is nitrostyrene. Nitrostyrene, the structure, the name of the structure is nitrostyrene. Actually styrene is, this is styrene. Okay, and the two hydrogen atoms attached to this carbon atom are replaced by nitro and this methyl group. Okay, so this is known as nitrostyrene. So nitrostyrene is then reduced, reduction is done on this nitrostyrene, and we are getting our target molecule, that is amphetamines. Okay, now what are the impurities? Again, this is the third method is different, so that's why the different impurities are found in this reaction. So this is what we called 1-methyl 2-phenyl azidine, 1-methyl 2-phenyl aziridine. This is a 3-membered ring containing nitrogen atom. It is called aziridine. This moiety is called as aziridine, 3-membered ring. Okay, and it is 1-methyl 2-phenyl aziridine ring is there, and this aziridine is formed as a impurity. Then the third most widely encountered impurity in this nitrostyrene synthesis is the oxime derivative of this benzyl methyl ketone. Okay, so this is NOH is the oxime derivative is formed as an impurity in this nitrostyrene synthesis. Okay, so these are the different impurities formed in the different synthetic methods used for the synthesis of amphetamines in all over the world. It is noted that as per the requirement, as per the available resources in the analytical methods or in the analytical laboratories, the chemists are choosing themselves the method chosen for the synthesis of amphetamines. This synthesis is done only for the analysis point of view. There is no any commercial point of view for the or behind that synthesis or behind that production. This synthesis is done in the milligram or microgram level. Okay, and that's why this is only for the purpose to compare the data of street samples, the samples that were obtaining for the from the society or from the market for the analysis. For the comparison point of view, we are synthesizing these amphetamines, that is controlled substances, in the laboratory. Okay, and our main point of view is that while doing this synthesis, which are the different impurities formed here, that we have to remember, that we have to see, and that's why impurity profiling is one of the important aspect in the synthesis of amphetamines in the laboratory. Okay, I think you got it. So we will stop here, and in next lecture we will wind up this amphetamines. Okay, and the only two subtopics are remaining, and we will see in the next video or in the next lecture. Okay, thank you very much. Have a nice day.